my talk tonight is a space-time guide to a sustainable future. And it's going to be the first in a series of lectures on science, technology, engineering, and mathematics, or STEM. In thinking about what I needed to talk to you this evening about, I was thinking, so what does STEM actually mean? Well, certainly, if you think about it in terms of learning, it may be something to do with sensitivity, tolerance, empathy, and morality. If you think about it in terms of an institute, it may refer to students, teachers, employees, and managers. If you think of it in terms of foothill, it may really refer to sports, teams, exercise, and marathons. But I'm going to talk to you about the STEM that has to do with sustainable technologies and environmental management. But before we get to that aspect of STEM, I want to talk to you about space, time, energy, and matter, or what matters. And so I thought, because we're starting outside and because we have over our heads the perfect example of sort of where we are, and that is we're in the context of the Milky Way. And so I want to give you this evening a very broad perspective on the human predicament. So let's go. Let's start at the Milky Way. So here we are, the Milky Way galaxy. The Milky Way is what's called a barred galaxy. And in the Milky Way galaxy, there are between 100,000 and 120,000 light years from end to end. To give you an idea about how big this is, if our whole solar system was the size of a quarter, the Milky Way galaxy would be 2,000 kilometers across. That means to say that driving here from San Francisco to LA, there and back, would be the size of the Milky Way galaxy if the solar system was the size of a quarter. If we think about our galaxy, it's somewhere between 100 and 400 stars. And you are here. The center of the galaxy has a black hole. And if we look out from our galaxy to what's called a local group, we can actually see stars forming. So we can see these huge phenomena where stars are forming. And the process of star formation has been modeled by Sandy Faber, a colleague of mine, who's a cosmologist at UC Santa Cruz of the Lake Observed. What you see is a well, a gravitational well in space-time in which the matter falls in to form stars. So let's look at some of the stars. Here's a large star called Antares. It's called a red giant. Notice the size of Antares. And notice the size of the star down below called Arcturus. Here's Arcturus. Here's Antares. Notice the size of Arcturus, and here's the size of our sun. Notice the size of our sun, and here's the size of the Earth. So our solar system formed at a pretty medium star, the sun, and the model of how our solar system formed is here. It's basically a disk of dust around our central star, and the planets swept out the dust and accumulated into the planets to form our solar system. If you look at the planets of our solar system, Jupiter, Saturn are the gas giants. Uranus and Neptune are rocky, icy planets in the outer solar system, and the Earth, Mars, Venus, and Mercury are the rocky planets close in to the sun. I usually talk about Mars for a while, but I want to tell you about some other things tonight. I want to focus in on the Earth, because the Earth is interesting, obviously, to us, because unlike the other rocky planets, the Earth is the only planet that has water left on it to any large degree. Venus had water when Venus formed, but the surface temperature of Venus now is over 400 degrees Celsius, 750 degrees Fahrenheit. The atmosphere of Venus is a thick cloud of CO2, and it's very acidic, mostly sulfuric acid. Mars has an atmosphere that's extremely thin. It's about 1% of the Earth's atmosphere, and it's a horrible place We may have some time to talk a little bit about Mars towards the end of my presentation. And Mercury is uninhabitable. Venus and Mars undoubtedly had water, like the Earth has got water in the early history. But Venus lost its water because the radiation from the sun broke the water molecules into hydrogen and the oxygen rusted the rocks and minerals, and the hydrogen escaped into the atmosphere. The same to a large degree happened to Mars, but it didn't happen to the Earth. And the key to Earth's maintenance of water is a crucial component of what our discussion will be tonight. The Earth is really a misnomer. It's a water planet. Most of the surface of the Earth is covered with water, 71%. And if we made the Earth into a perfect sphere, there would be about 2.5 miles of water covering the whole surface of the sphere. But let's talk about the Earth, Moon, Sun. In particular, we need to put this into perspective of time. So the Earth is 4.52 billion years old. So what does that mean? It's very difficult to understand time. And so what I'm going to do for you now is I'm going to model time by mapping it onto something familiar, a football field. So if we map a football field to equal 4.52 billion years over, let's say 100 meters, to be a little scientific rather than 100 yards, but 100 meters is our football field, equaling 4.52 billion years. So let's map onto this football field where things have occurred. We know by the formation of the Earth that in the early part of this football field, that is down here around the 10 and 20 yard line, the Earth was heavily bombarded with all those dust and rock particles that were building the Earth and the other planets as they grew. Early in the Earth's history, there was a massive impact, we think, that formed the Moon. Something almost the size of Mars, which was mostly a metallic object, careened into the surface of the newly formed Earth and formed the central metal core and broke off what became the Moon.